Cedar is a platform targeting the development of adaptive user interfaces for enterprise applications using a model-based approach. Cedar's primary aim is user interface simplification, which comprises role-based feature set minimization and layout optimization. Enterprise software applications include many scenarios where users with different roles require variable versions of the same user interface. Catering to this variability by providing multiple user interface versions will enhance usability. We will now observe a scenario that takes place at a virtual home appliances company called Apply Home. This scenario demonstrates an example of role-based variability in enterprise application user interfaces. We will observe two sales invoice transactions being issued. This is an example of a fully featured sales invoice user interface. We will observe how two employees with different roles in the enterprise require a variable user interface feature set and layout for the same business activity. A customer has just purchased a new microwave oven. Valerie, the retail sales officer in charge of the transaction, will be issuing the sales invoice. We can notice that the UI feature set of the retail sales invoice has been minimized to show only the required fields. By providing an uncluttered interface, Valerie can complete the transaction efficiently. Additionally, the layout was optimized by switching combo boxes with radio buttons and showing a higher accessibility of functions. The layout optimization in this case allows Valerie to control the UI in an easier manner through the point-of-sale touchscreen. Now we will go up to the second floor where another customer is purchasing a large number of electrical equipment. Mark, the sales officer in charge of wholesale transactions, will be issuing the invoice for this customer. The user interface feature set associated with Mark's role is much closer to that of the fully featured UI. We can notice that only the payments grid and totals were removed. Since Mark will be using a mouse rather than a touchscreen, the combo boxes were not replaced and a lower accessibility of functions is given. Adaptive enterprise application user interfaces can be developed with the Cedar Studio IDE and consumed as a service from different technologies using APIs and toolkits. We will briefly illustrate an example of devising a sales invoice user interface and simplifying it using our role-based user interface simplification mechanism, ABIS. By following a model-driven approach, user interfaces could be represented using Cedar Studio on several levels of abstraction. We are now going to observe the task model represented as a Concar task tree. We have already defined this model for the sales invoice and applied ABIS on it. Each task has a lock-shaped button for applying ABIS and a label indicating whether it is in an initial or a simplified state. Consider that we need to block the task called delete for the role cashier. The default policy called all roles grants access to all the users on all the tasks. To override this policy, we will assign the role cashier to this task. By setting the concrete operation to hide, the task's relevant UI elements will be hidden from the user. ABIS could also be applied to the task models using rules. This is an example of an ABIS rule written using SQL and associated with task models and roles. The SQL statement will return the tasks upon which to apply the selected roles and concrete operations. To ensure that critical constraints are not violated, Cedar Studio provides the ability to perform model checking using SQL-based constraints. For example, the following constraint checks whether certain tasks are not accessible to any user in the system. The SQL statement returns the tasks violating the constraint to be displayed on the screen as an error or a warning. If we go back to our task model, we can validate it against this constraint. We are now going to use the task model to automatically generate the second level of abstraction, namely the abstract UI model. Cedar Studio prompts us to conduct any necessary changes to the default mappings between the two models. We are now going to view the automatically generated AUI. Upon generating a model from another, a mapping is simultaneously generated linking the two models together. Manual modifications could be easily performed when necessary on any of the models by dragging elements from the toolbar onto the canvas as such. We are now able to automatically generate the concrete UI model that represents the interface in terms of graphical widgets. Similar to what we have previously done, we could change the default mappings between the models. We are now going to observe the concrete UI and conduct the necessary aesthetic modifications. We are now observing the final version of the UI without any adaptations. If we run the same UI using a user allocated the role cashier, which we used when applying ABIS on the task model, we can see that the feature set is minimized for this role. We considered that the role cashier also requires some layout adaptations, such as displaying a high accessibility of functions and switching combo boxes with radio buttons. This can be achieved using Cedar Studio by defining adaptive activity workflows that incorporate both visual and code-based constructs. We are going to define each adaptation in a separate workflow using visual constructs for the first one and runtime scripts for the second. The separation allows us to group workflows that could serve as alternatives. In the first workflow, we shall iterate around the UI widgets and change the simple selection widgets to radio button groups. In the second workflow, we shall call a script to set the accessibility of functions to high. This workflow defines an execute script element that calls a dynamic IronPython script. This simple IronPython function sets the accessibility level to high on all concrete UI widgets. We have now associated the workflows with the concrete UI and the role cashier. If we run the simplified user interface again, we can see that the layout has been adapted according to what we specified in the workflows. Users sometimes face exceptional cases where they would like to reactivate a feature or choose an alternative layout adaptation. Our client-side API supports this behavior through a user feedback mechanism. Adapted user interfaces show a chameleon icon in the corner. When the user clicks this icon, all simplification operations are listed. Feature set minimizations, set to be reversible by the user, could be unchecked and reversed. This also applies to the layout optimizations with an additional feature of switching one possibility with another. Consider that the user would like to bring back the memo field and set the accessibility level to low. We can see that the UI updates itself automatically to reflect the user's feedback. In this video, we demonstrated how Cedar Studio could serve as a generic IDE for devising adaptive model-driven enterprise application user interfaces. If you would like to find out more, you can visit our website.